Section 4.2, Adding and Subtracting Matrices. To add matrices A and B, first we need to make sure that they are the same dimension. After that, we just add their corresponding elements in each matrix. Here I have matrix A, which is a 2 by 3, and matrix B, which is a 2 by 3. So we've met our first condition that they are the same dimension. Now we just find the sum of matrix A and B, and to do that, we're just going to match up the corresponding elements in each matrix. A in matrix A is 1, 1. R in matrix B is 1, 1. Therefore, we'll find their sum. We're going to continue that process all the way through F, which is element 2, 3 in A, and we're going to find the sum of that to W, which is element 2, 3 in B. And we show that example here. Matrix subtraction is similar. If two matrices A and B have the same dimension, then A minus B equals A plus the opposite of B. For properties of equality for matrices, it's the same as we've had in the past. We have closure, commutative property for addition, associative property for addition, additive identity, and also additive inverse. On our first example, we want to find each sum or difference. Here we want to find the sum of these two matrices. The dimensions are a 2 by 3 and a 2 by 3, therefore we can perform that operation. I'm going to do the long way of finding the sum of each element and then actually performing that operation to find our conclusion. First, we have 3 plus 0, negative 12 plus 3, 0 plus a negative 7, 21 plus a negative 8, negative 11 plus negative 4, and negative 5 plus 5. Now just perform each operation in each expression. 3 plus 0 is 3. Negative 12 plus 3 is a negative 9. 0 plus a negative 7 is a negative 7. 21 plus a negative 8 is 13. Negative 11 plus a negative 4 is a negative 15. And a negative 5 plus 5 is 0. From now on, we'll just go from this step to this step. But if you need to perform this step, please do so. Again, we want to find the sum or difference. These are both a 2 by 2 matrix, so therefore we can perform that operation. And I set up my matrix. 7 minus a negative 3, that's 7 plus 3, which is 10. Negative 2 minus 5, which is going to give me a negative 7. 0 minus 7 is again a negative 7. And a negative 12 minus 0 is a negative 12. Again, I want to find the sum or difference. Here I have a 2 by 3, and in this matrix a 2 by 3, therefore I can perform that operation. Now I'm just going to match up each element in each matrix and subtract. 3 minus 0 is 3. Negative 12 minus 3 is a negative 15. 0 minus negative 7, 0 plus 7 is 7. 21 minus a negative 8, 21 plus 8 is 29. Negative 11 minus a negative 4, negative 11 plus 4 is a negative 7. And a negative 5 minus 5 is a negative 10. A matrix equation is an equation in which the variable is a matrix. We use the previous addition and subtraction properties of equality to solve matrix equations. In the past, we've had problems that look like this in algebra. Very simple equations. X plus 2 equals 8. In matrix equations, the 2 will be a matrix and the 8 will be a matrix, and I'll be solving for X. We're going to do this as we have in the past, which is use inverse operation. We'll subtract 2 from both sides, eliminating this matrix, and then performing this operation, which just gives us 6. But in this case, it will be 2 matrices. If we have a situation that looks like this, we have not performed multiplication with matrices yet. So what we're going to have to do is inverse operation to move the x. That will give us 3 equal to x plus 12. Then we'll subtract 12 on both sides, and that will give us our solution, which is a negative 9 equals x. So we're going to use these procedures to solve matrix equations. Let's take a look at an example. Here is our first matrix equation. I want to use inverse operation to eliminate this matrix. I'm going to add it to both sides. When I do that, my problem is going to look like this. I'm going to add this matrix to both sides. Now what I can do is just add these two matrices. We know by inverse operation that these two matrices will eliminate. 5 minus 5 is 0, 0 minus 0 is 0, negative 3 minus a negative 3 is 0, and a negative 20 minus a negative 20 is 0. Now all we have to do is perform the operation, which is to find the sum of these two matrices. Therefore, I just add the corresponding elements. Negative 2 plus 5 is 3. Negative 5 plus 0 is a negative 5. 3 plus a negative 3 is 0. And 0 plus a negative 20 is a negative 20. We have another example, and here, as I've shown on the previous slide, that I have a minus x, and we haven't used this on matrices. So therefore, we need to move that x to the opposite side by using inverse operation. So I'm going to add x to both sides. And when I add x to both sides, that will eliminate this x on the left side. And what I'll get is an equation with x on the right side. Now I need to eliminate that matrix. I'm going to use inverse operation, so therefore what I'm going to do is subtract that matrix. And when I subtract that matrix on both sides, of course the matrix on the right side by inverse operation will be eliminated. And then I just need to perform this operation, which is to subtract matrices. And I'll just subtract each corresponding element. So a negative 3 minus a negative 1, negative 3 plus 1 is a negative 2. 7 minus a negative 4 is 7 plus 4, which is 11. A negative 11 minus 0 is a negative 11. 1 minus a negative 2, which is 1 plus 2, which is 3. 0 minus 5 is a negative 5. Negative 18 minus 7 is going to be a negative 25. To have equal matrices, you need to have matrices with the same dimension and also equal corresponding elements. So we need to prove two things: that the two matrices have the same dimension and the corresponding elements are equal. In this example, we need to determine whether the two matrices in each pair are equal. The first step is to determine their dimension. This matrix has a 2 by 2 dimension, and this matrix has a 2 by 2 dimension. So that justifies part 1. Now we have to see if the elements in each are equal. So I need to simplify the matrix on the left. 1/2 times a negative 5 is a negative 5 halves. When I divide a negative 5 by 2, that's a negative 2.5. 3.5 times a negative 2 is a negative 7. Negative 3 times a negative 1 is 3. And a negative 20 times a negative 0.2 is going to give me 4. Now we just verified that the corresponding elements are equal, and that would tell us that the two matrices are equal. Again, we want to determine whether the two matrices in each pair are equal. Let's check the dimensions. Here, this is going to be a 2 by 3, and this matrix is going to be a 3 by 2. Since the dimensions are not equal, these are not equal matrices. In this example, we want to find the value of each variable. I know that I'm going to subtract these two matrices, and I know that the corresponding elements would have to match the corresponding element on the right side. Therefore, I need to set up expressions to solve for my x, my y, and z, and also verify the negative 4. So to do that, I know that 3 minus a negative 2 equals x. Therefore, I know that that's going to be 3 plus 2, or x is equal to 5. Next, I can verify the value of a negative 4. That's going to give me is a negative 12 minus a negative 8 equals a negative 4. And that turns out to be true. -4 does equal a -4. Now I need to find the value of y. That's going to be a -11 minus a -3. The value of y is going to be a -11 plus 3, which is a -8. And my final value is z. That's going to be a -9 minus a -9, which is going to be 0. If I want, I could display that in a matrix. X is my first element, which would be 5, -4. Y is my element in 2, 1, which is going to be a -8. And z is 0. Again, I want to find the value of each variable. So I need to match up corresponding elements in each matrix and then solve the expression. Let's start with 4 and a -8. And when I solve for x with the -8 coefficient, I'm going to get x equals a -1/2. I'm going to start with the bottom corresponding elements to verify that the x's are the same. They need to be the same since I'm going to need the value of x in these two expressions. So that's going to set up 2.5 equal to 3x plus 4. When I subtract 4 on both sides, that's going to give me 1.5, a -1.5, which equals 3x. Converting this to an improper fraction is going to give me a -3/2, which equals 3x, multiplied by 1/3 on both sides, is going to give me a value of x equal to 1/2, which is what I needed to come up with. Now let's start with the other expressions. I know that 4x plus 6y equals 10. 10 equals 4, and we know that x is a -1/2, so I'll just substitute that in right now. Plus 6y. That gives me 10 equal to a -2 plus 6y. When I inverse operation, that's going to give me, adding 2 to both sides, 12 equals 6y, and y is equal to 2. Now what we need to do is verify that by solving for the next expression. That's going to be 0.5 equals 7 times x, which we know is a -1/2, plus 2y. That gives me 0.5 equals 7 times a -1/2 is a -7/2, plus 2y. I know that that's going to be 0.5 equal to, and a -7/2 is a -3.5, plus 2y. I'm going to add 3.5 to both sides. That's going to give me 4 equals 2y, or y is equal to 2. And that's exactly what I needed to come up with. So the values of x and y are respectively a -1/2 and 2.